any of the ones where there's a variable with a negative exponent, or if it says like 1 over x to the fourth minus 3 over x squared minus 4, these are all going to be what are called U substitution problems.
Oh, okay.
And the setup is whatever this middle thing is, that's your U.
Okay.
So you would write U equals x to the minus 2.
So 1 over u. Is that what? U squared minus 3 over u.
Well, U squared is going to, it takes this place. So it's like 3U here, minus 3. And then U squared is x to the minus 2 squared, which is x to the minus 4. If you've done it right, this always becomes U squared.
Oh, all right.
So this thing becomes, well, I went too far, but it becomes U squared minus 3U minus 4 equals 0. And this is what you know how to solve really well. These are very straightforward. So we have U minus 4, U plus 1. So if U equals 4, comma, U equals minus 1, but this is not what we're solving for. We need to remember that this is the case. So it's really x to the minus 2 equals 4, x to the minus 2 equals minus 1. Now is when you want to rewrite it with a positive exponent. So 1 over x squared equals 4, 1 over x squared equals negative 1. And then you have to solve this. So I would suggest cross multiplying here. So like 1 times 1, 1 equals 4x squared. Divide by 4, so 1/4 equals x squared. So x equals plus or minus the square root of 1 over 4, which is plus or minus the square root of 1 over the square root of 4, which is plus or minus 1/2. For this other one here, when you cross multiply, you get, you get 1 equals negative x squared. You move the negative 1 over, you get negative 1 equals x squared. This has no solution in the real domain. We talked the other night how this would be plus or minus I. But I don't know if it's looking for that.
I just looking for the plus or minus 1/2.
Yeah. Okay, so that takes care of 23. Where should we move to now?
25.
25. Okay, let me snip this. When you see a question like this on your exam, you are trying to find the common denominator. And oftentimes they're telling you on the left side, x plus 2, x plus 7, what this factors into. Not always, but in this case it does. 2 and 7, they multiply to 14, but add up to 9. Do you agree with that? Do you see that?
Yes, I agree.
Okay, so the point is that you need to figure out like what's missing over here. So I'm actually going to rewrite it because there's not a ton of room here. X plus 7 over x plus 7 plus, and then there's 3 over x plus 7, x plus 2, x plus 2 equals 5 over x plus 2, x plus 7. Do you remember from the other day what we said we would do here? That there's actually a step up here that I forgot to do. X cannot be.
Oh yeah, the bottom.
7.
Oh, I see.
Right. You have to do that first, and then you say, well, I can just look at the numerator. So that's x plus 7 plus 3 times x plus 2 equals 5. So go ahead and solve that. Let me know what you get for that, and we'll see if it's in the domain or not, if it's allowed or not.
x equals 2, and
I think
it doesn't work.
I think it's -2.
Wait, -2? Oh, never mind. My bad.
Yeah, I think x equals -2, and then this is not allowed.
Yeah.
Okay, so this whole thing, this whole problem has no solution. And that's
All right.
that if you have a test, and you will on this, you could see that. I mean,
Mhm.
it's possible. I guess we're going to continue by odds. So 27.
Yes, you got the right idea.
Okay, great. All right, so we're pasting that. Okay, this is another example of where the left side, x minus 3, x plus 3, tells you what the right side factors though into. But before we do that, what can x not be so that we're not dividing by 0? What are the excluded values here?
The excluded values of this would be plus or minus 3.
Exactly. We know that x squared minus 9 factors into x minus 3, x plus 3. That's difference of squares.
Mm-hmm.
It also helps you to figure out what is each of these missing. Well, this is missing an x plus 3. You have to multiply top and bottom by that. 4 over x plus 3. Multiply top and bottom by x minus 3. Equals 18 over x minus 3, x plus 3. We can then just look at the numerator. Just look at the numerator, because the denominator we've already accounted for with these exclusions. So that's x times x plus 3 plus 4 times x minus 3 equals 18. This is a quadratic. I believe you're able to solve it using some factoring. So go ahead and give that a shot, please. What did you get that this factors into? Jack, how are you doing on the factoring here?
Oh, I forgot to unmute myself.
Okay.
I got x plus 10 times x minus 3, and because x cannot equal plus or minus 3, it would only be -10 that works in this case.
That's right. So sometimes you have to even just cross that out to show that you got it, but it's not part of the solution space. Okay, 29.
Yes.
Okay, 29. So 29 is sort of like what we just
Then 25.
yeah, well, let me 25. No, this one is
Oh, I mean 20. Oh, never mind. Yeah.
this one's a little weird though, because so why did they do it this way? So let's write it. If you're not sure what to do, you can just rewrite it. Like this is 9 over x plus 4 over 6x minus 3 equals 2 over 6x minus 3. It may not look like it, but you can combine these two. And you can literally subtract 2 over 6x minus 3 from this side, and subtract 2 over 6x minus 3 from this side. And I'll write it out because we have the space here. So it's 4 over 6 minus 3 minus 2 over 6x minus 3. So it's like saying, okay, well, I got 4 of these. I'm taking 2 away. So what's left over?
2.
2. So it's plus 2 over 6x minus 3 equals 0. You should factor the bottom. Like this one doesn't really give you a ton. It gives you this. I'm sorry, 2x minus 1. This one doesn't help you out that much because this is an x over here. Like if we got something that was already over here, that would be good. So they're both missing the other piece basically. Like 9 over x is missing the 6x minus 3. So I'd probably just write it like that: 6x minus 3 over 6x minus 3 plus 2 over 6x minus 3. It's missing an x and an x. I did it again. What can x not equal here? What causes division by 0?
Division by 0.
Yeah.
For here, it would be plus 3. 1/2.
And what's the other one here? 9 over
The other
x.
one would be 0.
Good, good. Okay, so back to where we were. We now can only focus on the numerator if we want. So the right side is like 0 over 1s. I mean, you could multiply it by whatever. It's just going to become 0. So let's go 9 times 6x minus 3 plus 2 times x equals 0.
Mhm.
Go ahead and solve that and see what you come up with.
X equals 27 over 56.
54. This is 54x.
Oh, 54. Never mind. Oh, never mind. That's 1/2.
No.
27.
54. It is 27 over 56. That doesn't seem right.
54. No. 27 over 54. And
Yeah, but you got this 2x here.
oh, plus 2x. Oh, I forgot about that. Never mind.
So you subtract this.
Yeah,
54
56.
4x minus 2 times x times x. Yeah, so it ends up just being that fraction you just mentioned there. So it's 27 over 56, which is not 1/2.
Yeah.
But, so it's okay. All right. Any sort of anything else to review on that grouping of questions that you'd like to go over?
Yeah. Can we just get over to number 31A?
Okay. Do you have to do A, B, and C?
Just A.
Okay. How about for like the rest of them? Is it all just A?
For 31, 33, and 34. And that's it.
Okay. Let me snip that in. The knowing what the graph of this looks like is somewhat helpful. But if you only care about where something equals 0, 0 divided by a number that's not 0 equals 0. So this fact allows us to realize that all you have to do is set the numerator equal to 0.
All right.
Set x minus 3 equal to 0. That means you know that at x equals 3, this whole thing equals 0. Because let's just put 3 in. You get 3 minus 3 over 3 plus 5. Well, that's 0 over 8. If you have nothing to share and 8 people to share it with, nobody gets anything. That's why this is 0.
Mm-hmm. So is that just 0? ends up being the answer for this one?
No. This is the answer.
Oh. So it's just the numerator becoming
Yes.
0?
Yes.
So equals to, all right. On to 33a.
So 33a will be almost identical. You're just setting the numerator equal to 0.
But doesn't x minus 1 over x plus 2 equal 1?
Oh, I'm sorry. I was looking at 32. Okay, so this one is slightly different. Okay. Let me paste it. And yeah, there's more involved in this. So we care about where this thing equals 1. So you can cross multiply. That's probably the best thing to do here to get it. So you're going to find, though, that it's x minus 1 equals x plus 2. And you're going to realize, oh, this doesn't work. Because if you subtract x from both sides, you get 0 minus 1 equals 2. So
yeah, it doesn't work.
So what's going on here? Well, let me graph this so you can see here. I'm gonna do a new share, and I'm gonna go to Desmos, and we're gonna graph this, and you're gonna see why. Okay, so let's graph the left side. You were asking a lot about this, yesterday, like what's going on left side, right side. So does this ever equal 1? 1 is the blue line. What do you say there? Does it ever equal 1?
Sometimes I think, right?
Well, let's look. Maybe you're thinking it like gets there. Looks like they're just not coming together. So why is that? Well, let's look at let's look at this one. Y equals x minus 1, x plus 2. What's the horizontal asymptote of that?
Is it 1?
Y equals 1. And or we're getting to the point where you're supposed to realize, oh, if it approaches but never crosses that.
Mm-hmm.
So that's why this thing never equals 1.
Okay.
So back to the other screen, the thing is that we just said is that if I give you this function, it has a horizontal asymptote at y equals 1 over 1, which equals 1. And the graph just simply, it just approaches it from each side. It's gonna come down and say, okay, well, I look like that. That's an approach it. And then same thing from here. It's gonna approach, but never hit.
Okay.
All right, you said 34?
Yes, 34a.
Okay, so 34 is just like 33. So what I'd like you to do is cross multiply. This one actually does give you a nice numerical value. And see if you can find the value where this is true.
Would it be negative 1 over 1? Like to start it off when you're cross multiplying?
Yes, there's an over 1 here.
Okay.
Yep.
X equals 2?
Okay. So one way we can test that is I could just put 2 in to this. So is 2 minus 6 over 2 plus 2, does that reduce to negative 1? Well, negative 4 over 4, absolutely.
Oh, good.
All right, what else? What else are we going to look at today?
I'm going to send you pictures of some pages that I want to work on. All right, this should come in any second now.
Okay, well, I'll take a look here. Yeah, it looks like quite a few things have come in. Quite a few pictures here. Okay, so I see 4 pages, 3.2. Where do you want to start with this?
Can we start at number 1?
Okay, so 1 through 4, they're asking you to match the equation with the graph, and they're asking you to really, what they're trying to get you to do is understand what causes something to shift left, shift right, reflect up and down. So for example, let me go back just briefly to Desmos so that we can cover this correctly. And there it is.
It should be the graph B, right?
Well, I mean, sure. I mean, we can just say that, but like, is it clear why? Like, what does x minus 4 mean?
X minus 4 means to the right,
Okay.
4 units, and then minus 3 is down 3 units.
So right,
and it isn't reflected on the x-axis, so it'll open up
exactly
like a U shape.
So 2 is right 4 up 3, but it's also reflected over the x-axis.
Mm-hmm.
Okay, so that's and you know, you say, oh, well, which one is that? Well, I mean, 2 is A.
Mm-hmm.
Number 3 is left 4 and then down 3. Well, that's this one. That's letter D. And then we know this is C already, but why? Well, it's left 4, up 3, and reflected. I wonder if you're not seeing any of this.
No, I'm seeing it.
Okay, I wasn't sure because I had started a new share and then I had stopped.
All right, let's go on to number 5.
Okay. I have to move between screens. Got that up. Okay, number 5, it says for each quadratic function, write the equation in the form. Okay, give the vertex the parabola and graph the function. Okay, so you're going to be completing the square on this one. There is another way to do it, although I think completing the square is the best way. But you tell me, did you do something different in class?
No, not really.
Okay, because what some teachers do is they ask you to find the vertex. Like the vertex is at minus b over 2a, which is minus a minus 2 over 2 times 1. That's 2 over 2, which is 1. This h value, this x value is your h. So when you're trying to put it into this form, x minus h squared plus k.
Oh, for that vertex. I see what you
Yeah.
mean.
You can also find k by putting 1 back into the original. Okay, so like if you try to find p of 1, you get 1 squared minus 2 times 1 minus 15. That becomes minus 16.
The vertex is 116.
1 negative 16.
Oh, negative,
And
negative.
so that means your p of x looks like this. It looks like a x minus 1 squared minus 16. What that means is you have to find a. So the completing the square is sort of would give you a, but a is this number out in front.
Yeah.
In this case, a equals 1, so it's just x minus 1 squared minus 16. Once you get it into this form, b and c are very easy. B is the vertex. Well, we already found the vertex. It's 1 comma minus 16. C is a graph. We can look at the transformations. This is right 1 and down 16. So it's like here and then something like that. I would prefer to complete the square on these, but I understand. I understand why you why as a student you might not want to.
Alrighty. Could we go on to number 9 and 10?
Yeah. So 9 is we're gonna just do it the same way. What I'd like you to do is find the vertex for me for number 9. A is 1. B is negative 6. So go ahead and find both coordinates of the vertex for me.
Alrighty. So for A, we want isn't the vertex negative b over 2a?
Yes. So
Do we do this? Do we do that for number 5 because we got 2 over 1?
It was.
Oh no! Oh, now I see it. Okay.
It's minus b over 2a, yeah, and it worked out. So this one ends up being 6 over 2, which is 3. And then you got to put that number back in. You got to find p of 3. So do that for me, please.
All right. All right, so we got 3 and negative 9.
Perfect. Okay, so the a value is 1, so that allows you to immediately write it in this form. P of x equals a x minus h squared plus k. A is 1, so that's a 1. You don't have to write it. X minus 3 squared minus 9.
What would we do with that a again?
Well, it's 1. I mean, you could put a 1 here, but it's not needed. It's extra.
Oh, I see.
It's because of this. Like, these are the same. All right, I heard you say 10, so we'll look at 10 next. 10's actually really similar, so this will be good for you to try it on your own, and I'll give you the answer as soon as you're ready for it.
What does the graph look like, though, for number 9?
Oh, so you need transformations again. So transformations, this one is right 3, and down 9. So the normal graph looks like this, right? And if you're going right 3 and down 9, the vertex is down here, and then it comes up.
Now I see.
You don't have to be very exact because they're not asking for that, but you certainly can. Depends what they're trying to emphasize on that.
How do you usually find A?
It's just the number in front of x squared.
Oh,
B is the number in front of x, and C is 0 in this case because it says plus 0.
I see. All right, so vertex -2, -4, and the equation should be P of x equals x plus plus 2 squared minus 4.
Good.
Is that true?
Yep, you got it.
All right, good.
So it's a left 2, a down 4. It still opens up because A is positive. So it's you know, good.
Yeah, there's no reason to reflect it.
Yep, and then looks something like that.
Perfect. All right, and now on to number 14.
Okay.
This one's a little different. -4 in the front. What does that mean for equation?
Well, the first thing it means is it opens down. I mean, we talked about that a couple of times. The process is the same, though. You want to find the vertex, minus b over 2a. This time, though, a is -4, b is 4, c is 0, but you don't care about that. So it's -4 over 2 times -4, and that gives you -4 over -8, which reduces to +1/2. That's okay. You can certainly have a fraction for your vertex. It's totally okay. So now you got to put that number back in. You got to go find, okay, what's P of 1/2? And it looks bad. You're like, all right, I got to square a half. I got to multiply by a half. There are by far worse calculations to do, but.
So that would be -1 plus 2. And that's it. That's just 1.
So your vertex is 1/2 comma 1. Yeah. And that's okay. So now your A value is still -4. This is your A value.
Okay. So P of x equals -4 times x -1/2 squared plus 1.
Yep. Now, if you didn't believe it, if you're like, well, I don't even know if that's right. Well, if you expand this, you should get back to the original. So if you were to, FOIL this, multiply it by -4, everything, and then add 1, you'll get back to.
What does the -4 look like when it opens downward? Is it like wide, or is it
makes
thin?
it they call it, the word would be used narrower, but because it's stretched vertically, like it pulls it down. So this is right 1/2, this is up 1, but it's reflected and then they would call it a vertical stretch by a factor of 4. So what that does, and what did I say here? I said right 1/2, up 1. So there, there's your vertex, but then it's just much narrower. It would, look something like that. Whereas the normal one maybe looks, more on the outside, thinner. But it's really meant to be a sort of a vertical thing.
That makes sense. All right, can we move on to number 21?
Okay, so 21 is got a bunch of things: vertex, domain and range, equation of the axis of symmetry, interval over which the function is increasing, decreasing, min or max. This is probably, it's almost a full comprehensive list of everything that you could ask for. So
Shilling wants us to do 2 of these
which ones? Oh, okay.
These types of problems.
Okay. Well, A is asking for the vertex, and you know that from the previous problems. It's that point right there, or you can get it from the equation of the graph.
So we get -3, -4. All right. Now for B, domain range.
What is the domain always for these?
Oh yeah, negative. All real numbers usually.
Right. The range depends on whether it opens up or down. In this case, since it opens up, it's the y value of the vertex
to infinity.
To infinity.
All right.
The axis of symmetry comes from the x value of the vertex, x equals -3. It's this vertical line. Do you see how that's a symmetry line, that the left side looks like the right side?
Yes.
Okay, so a function is increasing, this is something new, if it's going up and to the right. So in this case, it occurs from the minimum, which is, but this is now an x value, the x value of -3 to infinity.
So -3 to infinity for this.
Yes, it is decreasing. So we have to describe what decreasing is. Decreasing is going down and to the right. So where I'm about to trace, it is decreasing.
Should be negative infinity to 3, right?
-3.
-3.
Yep. All right. State whether the vertex is a max, min, and give the corresponding maximum.
Minimum.
Okay.
Minimum at is it -3, -4?
So there's like it depends, like in a business calculus class, this comes up a lot, and it's really a full sentence. It's a minimum of -4 at x equals -3. The first part is what it is, and the second part is where it is. It's kind of like you saying, I live in a house on Main Street, wherever wherever you live. There's 2 parts to it. You have to say what it is and where it is. It's really a sentence, but you're not in business calculus, so you can probably just say -3, -4, and you get full points for it. Okay, you said there was one more here. Which one are we going to look at next?
Number 23.
Okay. So 23 is opening down. It doesn't change. Everything we just talked about applies, but what happens is as a student, we misinterpret what the words are for increasing and decreasing. So I'm really going to emphasize those a lot when I'm doing this here. So let's get the vertex. And it's right there. What are the coordinates of the vertex?
The coordinates of the vertex should be like -3 and 2.
Perfect.
Domain should be all real numbers. Okay. Range should be like parentheses or no.
So because it
Oh.
opens down, there's you have to learn the case when it opens up and the case when it opens down.
Is the bracket after?
Yes.
Is it going to be? Okay.
Because it includes the y value of 2. Like if you made a dotted line over there, like it actually could be 2.
So it'd be like negative infinity bracket 2.
Yes.
All right, good.
Okay. The equation of the axis of symmetry is the x value of the vertex. It's this vertical line, and you can see that everything is symmetrical over it. Okay, increasing. We said it has to go up and to the right. This is the part where it's increasing that I've just shown you.
Mm-hmm. So it'd be negative infinity to negative 3.
Yes. And then decreasing is
negative
from
3 to infinity, right?
Yep.
Perfect.
And this is a calculus concept, by the way, that you're doing right now. And then F is
Maximum.
the way I would want you to write is the max of 2 at x equals minus 3. Did we get everything? Because this is a great place for us to stop.
Yep, that was great. Thank
Excellent.
you, Matthew.
I'll send the notes and the video over shortly. Have a good night. Thanks, Jack.
I appreciate it. Thank you. Have a good night.
Bye now.
Bye-bye.